From that last kind of board, if profits are maximized, then using a bit more or a bit less of an input or a bit less of an input is better, should not increase profit, right? I mean, that's kind of definition of what a maximization is that X1 star in that kind of optimization criteria that we found at the bottom of that last board is the amount of input that maximizes, amount of input one that maximizes profit. You know, considering this constant level of X2, of input two. And so we're finding the profit maximizes the level of input, which means if we use a little bit more of that input, our profit should go down, or a little bit less of that input, our profit should go down. So this is the profit maximizing level of input, given that constant level of X2 is what X1 star is. So let's think about this graphically a bit, what we're kind of solving for. So remember, profit equals the price times output. Here, Y is our output. So think of that as like quantity. Price times quantity, that's total revenue, minus W1, X1, so the cost of using X1 units of input one, minus W2, X2 bar. Remember, we have this fixed second input. So we can rearrange this. We can solve for the output. Since we can express this, we can rearrange this so it's Y equals something if we want to express output as a function of profit. As a function of X1, and profit, because pi can be kicking around there as well, right? So let's just rearrange this well. Let's bring these terms to the other side. So now we have profit plus W1, X1 plus W2, X2, W bar 2, I guess, equals P times Y. Well, we can rearrange, let's divide both sides by Y and rearrange it. So Y equals pi over P plus W1 over P plus W2 over P times, so I'm missing an X1 there, sorry, and X2 bar over here. So I'm just rearranging that, putting Y on the other side, dividing both sides by P. We're going to call these lines isoprofit lines. So we can use this. Isoprofit lines. And so what isoprofit lines are going to be kind of these parallel lines where we're showing different levels of profit. So each isoprofit line shows all inputs that produce a constant level of profit. So we can have output, we're holding profit fixed on one line, and we're varying how much X1 we use, and that's showing all the different combinations of inputs that are going to produce a certain level of profit. And if we change that profit, we're going to be drawing kind of these parallel lines. And so let's erase this board and see what I mean by that. All right, so as we just saw, we have these isoprofit lines which are y equals pi over p plus, I'm just going to rearrange it slightly, w2 over p times x2 bar plus w1 over p times x1. As we change y, so these are all the different amounts of, we're going to vary x1, and that's showing us all the different combinations of x1 that are going to produce the same profit, basically, is what that's going to do for us. So as we change the profit level, what we're going to do is kind of change the intercept, and we're going to get kind of like a family. You're going to see, maybe it's going to be really clear when I draw it, but like we're going to get like a family of straight lines, and these parallel straight lines for different levels of profit. Straight parallel lines. With a slope of W1 over P, since it's just varying in X1, and an intercept of these first two terms. So, we're going to basically plug in pi, and that's going to give us an intercept and different combinations of x1 and this fixed amount of x2 that are going to produce the same profit level. It's going to have different levels of output. And if we change that profit level that we're looking at, those are just going to be parallel lines, where the higher the line, the higher the intercept, the higher the line, the higher the profit. If we think about it that way, the profit maximization problem is just finding the point on the production function that maximizes, that has the highest level of profits. Okay, so I think graphing this, kind of, all this stuff will be a little bit more clear. All right, so here's our Y, or our output. Right, the amount we're producing. Here's the amount of x1. This is our production function. Maybe it looks something like this. So this is f of x1, x2 bar. So what these ISO profit lines look like are these straight lines. So maybe here's an example where it has a slope of W over P, W1 over P. That's the slope, because x1 is the only thing we're varying. And it has a profit, or has an intercept of profit over P plus W2 over P times x2 bar. So here's one ISO profit line. So all these combinations along these, this amount of input and this level of production here will give you the same profit as this level of input and this level of production there. So every combination on this line, all these different combinations of x1 and x2 bar here, while we're varying as x1, is producing the same profit. And if we raise the profit, that's going to raise the intercept. And what we want to do is get on the highest ISO profit line possible. So we have all these intercepts. And we're going to find one that maximizes. They all have the same slope, W1 over P, W1 over P. And we want to find the one that's on the highest one. Well, that's going to be at this tangency point. That's essentially what we're trying to do, is use this much input, this much of level of input number 1, and that's going to get us on the highest isoprofit line possible. Well, let's think about, so the highest one possible is going to be where the slope of this isoprofit line equals the slope of this production function. Well, what is that point? Well, that point is exactly slope of isoprofit equals the slope of the production function. Well, this is going to be exactly what we got before. The slope of this isoprofit line is W1 over P. And the slope of this production function is the marginal product of input 1. This is the exact same expression that we got before. So this is kind of like how that maximization problem looks graphically, or a way to think about it graphically. We have these isoprofit lines that are showing different combinations of inputs that give us the same profit. The higher the intercept is on the line, why that's changing is because pi is changing. And so this isoprofit line has a higher profit level than this one. And we want to be on the highest isoprofit line possible given our production function. Well, that's going to take place where the slope of this isoprofit line equals the slope of this production function. The slope of the isoprofit line is W1, or the price of the input over the price of the output. This right here. And the slope of the production function is just the derivative of this production function with respect to x1. So how much production changes when we change x1 by just a little bit. Well, that's the marginal product that we learned about in the last chapter, in the last set of videos. And so this is the exact same result as when we did it kind of like the general algebra just a couple minutes ago, a couple boards ago. Just slightly arranged, right? We had price times the marginal product of 1 equals W1. This is the exact same expression. It's just we're dividing by P over here instead of multiplying by P over there, but the expression is the same. So that's kind of what we're doing. And think of this as like, it's like the equivalent tangency condition that we kind of talked about before.